So a complex number is any number that can be expressed in the form of a plus bi, and it has two parts. The a is your real part, so any real number, okay? And then your bi is your imaginary part. Okay, so a plus bi, that's the way that it is proper to be written. It doesn't mean that if you write bi plus a that it's wrong, okay? It's just we usually write the real part first plus the imaginary part. So some examples would be like what we looked at yesterday, 3 minus 5i. That would be considered a complex number. Okay, but you could also write a complex number as just like 3i. It's just your real part is missing. It's 0. And you could also technically write, here we go again, a real or a complex number as just like 5. I'm sorry, my pen's not writing. Because your imaginary part could be 0. Okay, so most of the time we don't call it a complex number if it's just a real number like 5. Okay, but you have to think that it could technically, you wouldn't write plus 0i. Okay, you would just write it as 5. But anyway, those are just examples of what a complex number should look like. All right. And what we're going to do today is we're going to start real simple. We're going to add and subtract them, just like we add and subtract regular polynomials. Okay. The only difference is we have real parts and we have imaginary parts. So your like pieces that you're going to combine your real numbers, the parts that don't have I. And then you're going to combine the imaginary parts, the parts that do have I. So much like we did with regular polynomials when we added and subtracted those, you have to be careful because when we throw all of this together, we're going to have some multiplying too. And even though we talked about that with regular polygons, I still had people multiply when they were supposed to be adding and subtracting. So you want to make sure you're paying attention to what is in between your parentheses. If there is a plus sign or a minus sign, you are simply adding and subtracting. Only multiply when the two parentheses are together. With the addition, it is not that difficult, but just like with regular polynomials, we want to make sure that we think about anything in front of the parentheses needing to be distributed and then combining our like terms. So with number 1, what's in front of both of my parentheses? That's not written. A 1, okay? So again, we're going to just imagine that we are distributing a positive 1, which does not change anything. Same thing here. We're distributing that positive 1. Okay, because that plus sign is in the middle, that means we are adding these. All we want to do is combine the like parts. My two real parts together, my two imaginary parts together. What are my two real parts? 6 and 2. So what's 6 plus 2? 8. And then I combine my two imaginary parts. A positive 3i and a positive 4i is going to give me a positive 7i. Okay. I cannot combine those any further because one has the imaginary number with it. The other one does not, just like we wouldn't do it if it were 8 plus 7x. So we're going to leave our answer just like that. Today is real quick and easy. Go ahead and try to. Same thing. We're adding these complex numbers together. You add your real parts with your real parts, your imaginary parts with your imaginary parts. Again, with the parentheses, there is a plus in between them, so we're going to think about distributing. And the only reason we continue to think about distributing is sometimes there will be a minus. So we will technically have to distribute and change things a little bit. So this is going to be -6 plus 4i because a positive 1 doesn't change anything. Same thing back here. It's going to be a +2 and a -3i. And then we combine our real parts. What's -6 plus 2? -4. And then our imaginary parts, +4i and a -3i are going to give me a +1i. And we cannot combine those, so we leave it just like that. Anybody have any questions? Okay. All right. Take a minute, write 3 down. We'll do that one. What's different about this one? There's a minus sign. So when I distribute at least to the second parenthesis, it will change just a little bit. The first parenthesis, we are still distributing a +1, so it does not have any effect. However, the second one is going to change just a bit. -1 times -4 turns that to what? +4. And then a -1 times a +2i is going to turn it to a -2i. And then we just do like we've been doing, combine our real parts together. A +8 and a +4 gives me 12. And then a -6i and a -2i gives me -8i. And then there's nothing else I can do because those do not have like terms. So there's when I distribute it. All right, again, we're going to distribute the negative to the second parenthesis. In front of the first is still just a +1, so that's going to stay -8 and a +6i. But when we distribute here, -1 times 10 gives me -10. -1 times a -4i gives me +4i. Then we're going to combine the real parts together, the parts that don't have the i's. What does -8 and -10 give me? -18. And then a +6i and a +4i give me a +10i. Everybody okay with those? Not hard stuff, right? All right. Try those two. These are the last two. What did today's read? Attention to what's in between your parentheses, whether it is a plus or a minus. If it is a plus, really nothing is going to change. If it is a minus, what's in the second parenthesis will. Then combine your real parts together and your imaginary parts together. With number 5, it is a plus sign in between, so I'm going to be adding. And again, think about that positive 1 there. It's not going to change the first parenthesis. It's also not going to change the second parenthesis. And then when I combine my parts, what is a positive 6? Come on. Positive 6 and negative 6 give me? 0. They cancel out. I don't have to write 0, but I could if I wanted to. And then a positive 10i and a positive 5i give me a positive, try to write that properly, 15i. So if you wanted, you could put 0 plus 15i, but you can also just write it as 15i. And then with number 6, again, we have a 1 in front. I do have a minus sign, so that will change the second part. Negative 1 times 4 gives me a negative 4. Negative 1 times a positive 2i gives me a negative 2i. Combining my real parts, what's 8 minus 4? 4. And then when I go to combine my imaginary pieces, what happens to those? They cancel. So you could write it as 4 plus 0i, but also I would just write it as 4. Okay, you don't have to put the zeros in there if either part of your complex number cancels out.